Okay, in this video I'm going to talk about how to analyze the graph of a first derivative in order to draw conclusions about the original function. I've just drawn a very rough first derivative graph. We can see right up here, this is the first derivative, not the original function, and we're going to have to look at this to interpret things about the original. So the first thing that we want to do is right here, we want to state the values of x in this interval from -6 to 6, where f of x has its minimum extrema. So we're looking for minimums here. Now, as a reminder, if I'm looking for anything from the first derivative, right, if I'm looking for anything having to do that first derivative, which are going to be things like increasing, decreasing, minimums or maximums, or critical values, which are also called horizontal tangent points, I'm going to be looking at just the y values of this graph. So I'm just looking at whether this graph is above the x-axis, below the x-axis, or right on the x-axis, right? Positive, negative, or zero. That's going to tell me everything that I need to know about things from the first derivative. So the minimum is from the first derivative, so I'm just looking at the y values. Is it up or is it down? Is it above the x-axis or below? That's it. So since I'm looking for a minimum, I'm looking for somewhere where my original function goes from decreasing to increasing, right? So where the slope of my original function goes from negative to positive. And since I'm looking at the slope of my function right up here in this graph, I'm looking for places where my function goes from negative y values to positive y values. So that's going to happen in a few places. Let's go ahead and point them out. This entire area here, from -6 to -2, my function here, my f prime, is above the x-axis. That's positive. That's going to mean a positive slope. So I'm looking for places where it starts at a negative slope. So I'm looking here, my negative y values. And I'm not looking just for negative y values, but where they change from negative to positive. So I'm looking right here at 0, I change from negative y values to positive. So x equals 0 is my first minimum. And remember, we're only talking about x values. I can't get y values out of this graph. I can't get y values without that original equation or the original graph, and I don't have either one of those. So I'm only going to make conclusions about the x values because they line up on all of the graphs and their derivatives. All of the x values are the same. So I know x equals 0 is my first minimum. I need to check to see if there are any more. So over here I'm positive and it goes to negative, but that's not a minimum. That's actually going to be defining a maximum when I go from a positive slope to a negative slope. So I'm going to continue on and I see that I have another minimum right here at 4. I go from below the x-axis to above, so that makes 4 my minimum. And if I want to justify that, which I should, I can say that this is a minimum. These are minimums because f prime changes, and not just that it changes, but that it changes from negative to positive y values. I have to be specific on this guy. All right, so that was my first problem. I have another problem over here asking, where are the critical points of my original function? So the critical points of my original function, this can also be phrased as, where do I have horizontal tangent lines? So where does f have horizontal tangent lines? So horizontal tangent lines, again, happen when we are curving in such a way that our slope is 0 at one point. So on the little doodle that I've drawn, I have a horizontal tangent line here. It's important to note that it doesn't have to be at a maximum or a minimum. For example, if my curve continues on this way, I still have a horizontal tangent line right here. Even though I go from increasing to increasing, I still have a 0 slope for just that 1 second. Then over here, I go from increasing to decreasing, so my 0 slope actually means that I have a maximum. So I'm just looking for the horizontal tangent line. So I'm just looking for those critical points. And we know we find the critical points by taking our first derivative and setting it equal to 0. So when I'm looking at the first derivative and I'm looking at my first derivative graph, I'm just looking for places where it actually equals 0. I'm not looking for positive or negative. I'm just looking for where it is 0. So everywhere that it touches the x-axis. So let's go ahead and find those points here. It looks like I touched the x-axis right over here at x equals -6. And again at x equals -2, x equals 0, 2, and 4. I have quite a few critical points. So I'm going to go ahead and list those. I have x equals -6, -2, 0, 2, and 4. And when we justify this, we can say that these are critical points because f prime equals 0. So critical points are right on that x-axis where it equals 0. All right, for my next question, I'm going to go to another sheet of paper here. So our next question is going to be, state where f is concurrently concave up and decreasing. So I want these things to be happening concurrently. I want them to be happening at the same time. So I'm not just looking for one or the other. I'm going to identify both things, and then I'm going to find out where they're happening at the same time, right? So if I need f to be concave up, this is going to come, concavity comes from my second derivative. My second derivative has to do with anything dealing with concavity or points of inflection, right? So if I'm trying to find where I'm concave up, I'm looking for my second derivative. My second derivative is the derivative of my first derivative. And derivative is the same thing as slope. So if I'm looking for the derivative of my derivative, I'm looking for the slope of my derivative. So I'm not looking at y values anymore. If I'm talking about concavity, I'm talking about slope, uphill or downhill, or uphill. There we go. Now you can see it. So when I read from left to right, am I going downhill or am I going uphill? This is all I have to look at to find my second derivative. So if I'm looking for concave up, I'm looking for places where my function is going uphill. And I can see that that's happening here. From -6 to -4, I'm going uphill. I can also see from here, -1 to +1, I'm going uphill. And one more time here, from 3 all the way to 6, I'm going uphill that whole time, right? So that tells me all the places I'm going concave up. Because my slope is positive, which means my derivative of my derivative is positive, which means that my second derivative is positive. So that's one part of this. I also find where my equation is decreasing. Decreasing, remember, comes from the first derivative. And if we're looking for something that comes from that first derivative, as we remember from over here, first derivative, increasing, decreasing, minimum, maximum, and critical values, that comes from my y values of my graph of my first derivative. So if I'm looking for everywhere that I'm decreasing, I'm looking for everything with negative y values. That's going to tell me that I have a negative first derivative, so I have a negative slope, so I'm decreasing. So my negative y values happen below the x-axis. So that's going to happen here from -2 to 0, here from 2 to 4. So what I'm looking for in this specific instance is I'm looking for places where I'm concave up and decreasing, where these kind of values overlap. And I can see that quite clearly now that I've labeled it. I am both concave up and decreasing from -1 to 0. So I can say from -1 to 0. And again, over here, I can see that I'm concave up and decreasing from 3 to 4. So in these two small intervals, I am both concave up and decreasing. These are x intervals. And when I justify this, I can say that I know that this is true because two reasons. My f prime graph is both negative That tells me I'm decreasing, and has a positive slope. Slope tells me about that concavity, right? So it's negative and it has a positive slope. Negative function, positive slope. That tells me